Hopefully you guys can see me. Hello, I'm Omar, owner of AC Power and Comfort. I'm out here in my own garage right now before I head off to work. This video is for a request from Redstone College in Denver, Colorado. My name is Omar again, and this video was requested by Ruben Crespo, which is my brother from Denver. He's actually now ventured off in a new field, which is the trade, which is an excellent decision in the HVAC industry, where this industry is actually never going to go anywhere. It's always going to be needed. So anyways, moving forward today, the request was more or less how to actual hookups when you do a recovery from the unit, when you're using a recovery unit, recovery tank, just more or less when you're recovering refrigerated from an AC system out there. Just to let you know, AC Power focuses on industrial and commercial equipments only in the field. We do not focus our industry in residential. Again, we're just dealing with heavy equipment out there for medical facilities, schools, as well as commercial buildings, offices. Anyways, let's move forward here. This again video is to show how to hook up your hoses to do a proper recovery, as well as then to push the same refrigerant that you recovered back into the system if it is not a burnout. Anyways, we're going to go over some items here real quick. This is a recovery tank, 123 pound recovery tank. You might not need this yet, only when you deal with heavy commercial like chillers, some Liebherr systems, Aeon units out there that you have to recover almost well over, I would say, anything greater than 50 tons of cooling. Anyways, let's move forward. Here we have a small recovery recovery tank, which this will probably be more used for residential, okay? And then we have also a 50 pounder here, which is actually used to recover as well. So this is 50, 25, 123. We have a nitrogen tank here, 100 pounder. I also have a 60 pounder in the truck. I'm not going to take that out right now, but majority of the time this is what I use out there in the commercial field and industrial, whenever I'm dealing industrial equipment. So larger equipments, this is the type of stuff that I use. Here is a vacuum pump. This is a 12 CFM. This is something that you should invest in if you're in the commercial for refrigeration. This actually helps a lot pull down the system into a deep vac. Also, it can help if you have a leak in your system. This little device here is a micron gauge, a digital micron gauge. It's connected in series. Up here you can see the port, so it's connected in series to the hose line, so that you can get 500 microns or less, or if it's reading stable. This right here is our recovery unit. And this is a twin. They also have a single. The twin, as you can, it's a little more faster when you do recovering. One of the good things to know is that if you're out there in the commercial field and you're dealing with heavy equipment, heavy commercial equipment, and you're recovering refrigerant, it's always good to have a drum, a bucket, like a garbage can, and have some ice. Because the thing is, when you actually submerge this tank into ice, you bring the pressures much, much lower. This tank will not get hot because, again, when you're recovering and you're pushing refrigerant and pressurizing it into a tank, that pressure starts generating friction and it starts to get hot. So for more faster recovery, put any tanks that you might, let's say you're in the commercial where you have to move fast, icing your tank or submerging it into a bucket with ice will be fast, or just pouring water over it as well. Anyways, let's move forward here. I didn't share this device over here. This is a gauge. This is my digital gauge that I use normally in the field. It has these connections, clamps for subcooling, superheat, readouts, temperature, line temperature as well for suction and liquid. It reads temperature more or less. So and then when you do the actual punching of the keys in here, you get subcooling and superheat. So anyways, for the basic, what you guys have, you guys disregard this section of the manifold. You only have the left and right. So here you have your blue side, which is your low side gauges. This gets connected to your suction side of your condenser unit. On this side, you have your high side gauge. This hose gets connected to the liquid line side of your condenser unit. The center gauge, the center hose of your manifold. This gets connected to the equipment that you're actually going to be using. So this gets connected to the refrigerant drum, recovery unit, or the vacuum pump that you're going to be using. So basically, these two right now are actually, let's assume that these two right now are actually connected to the actual condenser. Okay, so right now we're going to recover the refrigerant in the system. So your high side, your low side, your manifold gauges are closed, and your center hose, which is your yellow hose, that gets connected to, let's hang this back up over here. This gets connected to your in port, the inside of the recovery unit. Again, you want to suck from what's inside the actual condenser through here. And then I use a black hose because, when you do any type of recovering or any type of vacuuming, black hoses are good because they're more stronger. Anyways, this hose gets connected to the out, because now you're taking what is in the condenser out of it and you're pushing it into a tank. On these tanks you can see they have a blue and a yellow. Okay? The blue is vapor on this one. And not a blue and a yellow, blue and a red. Blue is vapor, red is liquid. It's good to take it out as a liquid. So you put it into the liquid side. Once you're all connected and everything, what you have to do is make sure that you open your high side. Do not open up your low side yet. Again, do not open up your low side. Open up the high side. Once you open the high side, refrigerant's already going to start flowing through the red hose through the yellow hose, which is your center, and then it's going into the import of your recovery unit. Then after you open these gauges here, these valves, refrigerant's flowing through, comes out of here, and then goes into your recovery tank. Okay? That is the recovering method when you recover refrigerant. Once you do not see, if you have a sight glass on your manifold gauges or on the center, and you do not see any more liquid flowing through, then you can open up your suction side and start recovering vapor from the suction side of the system, the low side. So that's about as much as I can say until you reach 0 psi or a negative 5, negative 10. If you're in a vacuum, sometimes it's good because you don't want to have that oil inside there, because sometimes when you do sweat lines, there's some oil residual residue inside there that when you do sweat it, all of a sudden, when you're having torches to it and you pull that actual copper joint loose, sometimes flames can come out. So sometimes it's always good for safety reasons. Make sure you pull a vacuum when you recover it, that you're into a vacuum when you're recovering the refrigerant from the system, so that you don't have no oil inside there. Another good thing is after you recover it, it's always good to pull a vacuum. That's even more of to know that there is nothing else in the system. That's what I do in the field, because being in the field, I've noticed that sometimes when I'm out there and you have these line sets that are actually almost like a P-trap kind of, there's oil in there. Believe me, there's oil inside there. So just a good rule, pull a vacuum after you actually recovered. So that's just to eliminate any oil, and just when you're in a commercial building, it's a safety thing. You don't want to trigger any type of, even though if the building's on a test, you don't want to or burn anything or burn yourself, because when that pressure starts to build, when you start sweating, pressure is starting to build if there's oil inside there. And when you pull that line, sometimes you do get a burst of flame coming out, because again, the oil is flammable. Anyways, moving forward, as I was saying, just make sure you pull a vacuum on the system after you recover it. It's one of my things that I do, but eventually when you guys are out there, maybe you'll find out for yourselves the reason why I pull a vacuum after I recover the refrigerant from the system. Especially when I'm at the air handler and I have to sweat and the joints off the air handler. So anyways, let's go here. Now that we've already recovered the refrigerant from the system, now we're going to reverse the process, and we're going to push the refrigerant back into the system. Okay, so basically now that we recovered, we're done. We're going to push the refrigerant back into the system. This is what you do. Now that you can leave this gauge on the system, okay? Leave this gauge, this hose on the recovery tank. The only thing that you're going to do is you're going to switch these two. You're going to switch these two gauges, these two hoses, from the outside and the inside. So now what you're going to want to do is you want to pull from the condenser, from the recovery tank. You want to pull and you want to bring that in to the recovery unit. So you're going to be sucking what's in here. You're going to suck it out. And you're going to push it. This is where the actual term push-pull method. So you're pulling from the recovery tank and you're pushing from the recovery unit. You're pushing it out to the condenser again. That's basically as it gets. When you are pushing it, push and pull and push, more or less. You're pulling, again, from your recovery tank, and you're pushing out from your recovery unit into your condenser. And then the same protocol is when you actually open up your high side gauge on the liquid line side, so that you're pushing the refrigerant back into the system. Okay? It's very simple. This is the only switch that you have to do. It's faster. So you're pushing the refrigerant back into the condenser as much faster, so there's less time out there spending in the field. Now, I think I was pretty much clear on how to do a recovery and push-pull when you're actually pulling and pushing the refrigerant back into the system. Okay, and as of right now, let's go over the steps here when you're out there in the field. When you're out in the field and you have a leak on a system, and let's say you put your gauges on the unit and you do verify that pressures, let's say suction's around 30 psi, and your head pressure, your high side's around maybe 130 or 120, around there. You know that the system's low. The system is actually, and there's no icing, there's no iced up or nothing on the evaporator coil. You don't see no ice up on the actual suction line. It's just low. You see it's bone dry, more or less. It's the suction line is not sweating, it's dry. You know that there's the system's low. It's so at that time when you have that pressure inside there, you have to use your senses. observe and look around. See if you see any oil. Check the evaporator coil section in the air handler. See if you see any oil drippage or stain somewhere. Also check within, like, maybe, as I'll say, 6 feet of the refrigerant piping when it's insulated, because sometimes joints are sweated inside there, where you can actually, when you remove that insulation, you see some oil inside there as well. That's a sign where leaks are. Check the condenser, the fins on the condenser, seeing if they're stained. Check the actual filter dryer, seeing what conditions it is in, if it's rusted. Those are telltale signs. Again, you're looking for oil. If you don't see oil, then that's when you bring your nitrogen tank and you pressurize that equipment up to, me personally, I pressurize that up to 600 psi. I want to find a leak. That's what I want to do. Sometimes leaks can be hairline fractures, and pressurizing it up to 300 psi sometimes just doesn't work. Again, you'll experience this in the field. Sooner or later you will experience it. So pressuring it up to 600 psi with a little bit of refrigerant in the system, definitely that is the route to go. Once you pressurize it up to 600 psi, what you want to do is basically take your electronic leak detector and basically start sniffing around, or you can use soap bubbles, because at 600 psi, believe me, you'll hear something whispering to you, or you'll start to see, when you apply soap bubbles, you'll see either if it's in the evaporator coil, or if it's at a sweated joint, or if it's at an actual Schrader valve, etc., or any type of pressure controls. If the system has safety controls like a high and low pressure control, and sometimes it can sweat. Sometimes it can leak around the actual plastic that's actually joined to the actual copper. I've seen that happen. I've experienced that. So check areas where there is joints made. So if you do not see any signs of oil leak anywhere, then if there's no oil leak, it's more of a vapor leak somewhere on the refrigerant line somewhere between the evaporator coil or the condenser. So after you find your leak, basically you pressurized it up to 600 psi, you deplete the actual nitrogen in the system. After you deplete the nitrogen in the system, because what you're going to have left in the system at 20 psi or 30 psi of suction, you're actually going to have vapor in there. You're really not going to have any liquid. Okay, and then actually having it, say 120 psi on the high side, you're not going to have liquid in the system. It's all vapor that's in that system right now. Okay, so you can go ahead and deplete the nitrogen that you actually put in the system, and whatever's left, you might just want to go ahead and if you're like at maybe I would say 50 psi, go ahead and recover the vapor that's in the system. If that would be a good rule, because OSHA regulations for EPA, there's a minimum of depletion that actually you can actually do. I don't remember the actual amount, but again, let's just say, for a good rule, let's try not to deplete any refrigerant out into the atmosphere. Let's try to recover all the refrigerant in the system. But again, you're depleting the nitrogen. When you get down to like 50 psi, go ahead and connect your recovery unit and reclaim or recover the actual refrigerant from the system. After you have recovered the refrigerant from the system and you pinpointed the leak, you make the necessary repairs if it is repairable. If it is not repairable, then you go on and you just have to quote for a change out of either the evaporator coil or the condenser itself, or sell them a new system, more or less, as an upgrade. But after you have done the necessary repairs, let's say you have made the repairs, now what you do is you repressurize that system again. You can pressurize it up to 400 psi, or 500 or 600 psi again, and make sure that you don't have any leaks there. When you actually, also, just to let you know, when you open up a system already and it has a leak, always change the filter dryer. Always change the filter dryer. Put a new filter dryer. It's the standard protocol. Any R22, any 410A, 134A, standard protocol. Open up system, change filter dryer. So after you have done that, basically the next step is, after you have pressurized it and you have confirmed that there's no more leak, you deplete the actual nitrogen in the system, and then you hook up your vacuum pump. I have a different vacuum pump here. Again, mine's a 12 CFM, so mine has a larger port here for connection. So when I connect my vacuum pump, I'm connecting it here. I have thicker hoses here, so I have a faster, greater amount of, a faster pull, more or less, to pull that system into a vacuum. And when I put that system into a vacuum, I hook this up, this micron gauge, basically. To the system. Again, this gets connected in series. If you have a cap on this side, you can also connect it as not as in series. You can just connect it here, or you can remove this off the top and connect it here. And basically, I just have this line open. Again, you guys are totally different with your gauges. So as of right now, this gets connected just like this. You can connect it onto your centered hose, which is the yellow hose on your manifold gauges here. You can connect it on there, while these two are actually connected to your high and low side of the system when you're pulling a vacuum. But you guys might only have 3 connections versus I have 4 connections. So this is going to be the part that you're going to be using for your vacuum pump. So then you would have to put this in series in the line somewhere. So that's when you bring this little device in and then connect the leaving port to your vacuum pump. So anyways, when I am pulling a vacuum, I'm pulling a deep vacuum with this 12 CFM here. I can pull a vacuum on a residential or 2.5, 3 ton, 5 ton system within like 30 minutes or 15 minutes, I would say. I like to pull a deep vacuum. I like to make sure that there's no oil left in the system. I like to leave it bone dry. Another good thing is when you actually put a new filter dryer, sometimes it's good to put a sight glass. That is also, some of these units don't have sight glasses. Put a sight glass in there. This is a sight glass right here. This is your sight glass right here. Put a sight glass in there. It's a tool that can help you more or less find out if your system's how you say, dry or wet, or you also have if the sight glass is cleared, or if it's flashing, or if it's bubbling. It's good. It's a good part to put inside the system. It's more like a telltale sign to help you move forward on any type of diagnosing of the equipment, as well as knowing that you're fully charged. After you pull the vacuum on your system, you want to make sure that it ends up being stabled, or 500 microns or less, and you have if you have a digital one, that it's reading stabled and it's holding. That means when it's holding, you have no leaks in the system. If it is not holding, it could be 2 things. You might have a leak in the system, or it's still boiling off the oil or the refrigerant that's left inside the piping. because when you start pulling a vacuum, that oil will start to sometimes build pressure back into the system, where then it starts increasing pressure, and then it starts boiling off more or less. So that's what you want to do. You want to make sure that you are boiling the refrigerant or the oil that's in the system. You want to completely remove it. So basically, that is the standard protocol when you actually pull a recovery. When you actually are pulling a vacuum on the system. After you pull the vacuum on the system, you close everything off. I'm closing everything off. I'm reconnecting this hose back to the side where it belongs real quick. Alright. Now that the system is holding a vacuum, and you have put your filter dryer, your sight glass, and you're at 500 microns or less, and your system is holding, now it's time to add the refrigerant. We're going to use this drum here as our refrigerant drum. I'm not going to take anything off my truck right now. And let's say this is R22, okay? That's the most common one out there in this field right now. R22, upside down, just real quick, is liquid. Upside right up, right side up is vapor. So you want to charge it as a liquid. And then when you charge it as a liquid with your hoses already connected to the low and high side on your condenser equipment, what you want to do is you open up the actual valve on the refrigerant drum. Okay, all your hoses should already be in a vacuum. If you have these how you call these quick release gauges, but if you don't, the center one, let's go ahead and connect this. The center hose, like a prime example, I'm going to take my yellow hose off right now and use my black hose, because my yellow hose is a quick release. This one here, now that I have disconnected it and I'm reconnecting this to the actual refrigerant drum, there's a hole in here, of course. And already, when I open this to amp for air, already air gets inside here. Air is traveling inside here, because there's a vacuum already in this hole, so it's going to pull that air. Once that air is in there, what you want to do is you want to purge that air out. So when you actually put this equipment upside down as a liquid, your tank as a liquid, what you do is you open up slightly right here. And what's going to happen is, I should have something in here right now. And when it actually, let's go ahead and close this off. Close this off. Make sure that your high and low sides are completely closed off after you have pulled the vacuum. So remember, after you pull the vacuum, you're closing everything off. Okay? Vacuum, gauges, that's basically what you have to close off. Now, I'm going to go ahead and purge. Remember, this tank is upside down on your refrigerant drum. This is a recovery tank, so I'm just using this as an example of a refrigerant drum. This is upside down. Alright? I have refrigerant now flowing through here. Purging is this. That's a purge. That's all that you have to do. Once you see that mist, you close it up real quick. Okay? And now that this system is completely, this hose is completely evacuated from air, it has refrigerant in it, that's when you go on and you open up your high side. You open it up, refrigerant starts to flow on the liquid side, and now you are charging the equipment. And when you charge the equipment, weigh your refrigerant in. Always have a weight scale. Weigh it in. You also want to make sure that you're properly charging with the actual, the required weight for this specified equipment. And then also, good thing, good rule is labeling. After the amount of refrigerant that you have put in, label it. Don't do what other technicians out there do, where they just put the refrigerant and they go on about their way. And then whenever they have another service call or another AC company goes out there, we don't know how much refrigerant is in the system. Please, just, try to make things easier. I'm trying to pass the buck where we should change things a little in the field. Label things. Label the amount of refrigerant that you have used and that you have put inside that system, so that for any future AC or any other technician in that same company comes back, they already know how much refrigerant is supposed to be added, and also helps with billing, etc., because we charge by the pound. Anyways, when you charge a system and then you label it, also if you're using the new R22, okay, the new R22 that they have out there, 407C, 422B, 422D, or they're using MO99 as well, just go in there and label it with the sticker that it's either MO99, 10 pounds, 6 pounds, R22, 10 pounds, 6 pounds, label. I just want you guys to get into the rule of thumb, doing things the proper way, so that, you look professional. You know what you're doing. So do things by the book when you're out there in the field. Don't do things half-assed, because half-assed ain't going to get you nowhere. And but anyways, that's after you have charged the system. Basically, what you want to do is, majority of the time, pressure will start to equalize on the system. When pressure starts to equalize in the system, you can go ahead and, I forgot to say one thing. On the system, you already have your suction front seated and your liquid line back seated. Okay, that's when you actually have charged it up as a liquid. You can go ahead and open up your suction side and allow the pressures to equalize in the system. And after you have done that, you can go ahead and turn the system on. After you turn the system on, give it about maybe 5 minutes of run time. You might have to add a little more refrigerant. You add it as a vapor on the suction side. I don't recommend doing it as a liquid. Some people do it as a liquid because it's a little more faster when the compressor is actually operating and it's pumping. But do it as a vapor just to protect the compressor. In the field, you'll see that you're going to end up doing it as a liquid, because sometimes you got to move fast. I just want to tell you guys the proper way. Charge the system per vapor, because a compressor is vapor in and vapor out only. So anyways, after you have charged the system, make sure that you also put new core valves. New core valves in your where you connect your high side and low side ports, and put new caps that have rubber grommets in them. If the caps are missing, put new caps. Do not leave that job site with missing caps. That's like one of my pet peeves out there in the field. So I'm just trying to share this with you so that you guys do things the right way. Put caps, straighter valves, change them out. Whenever you are, when it's a system that was found with a leak. You want to eliminate any possibilities. So again, I hope this video was pretty self-explanatory. I hope you understand the protocol, procedure that you have to do. So again, my name is Omar, AC Power and Comfort. I hope this video was somewhat helpful for your newbies out there that are wanting to get in the HVAC field. Again, this is very basic as it gets in the field right now when it comes to recovering refrigerant, push-pull, vacuuming your refrigerant, vacuuming your system out, and putting refrigerant back into the system, and making sure that you're charging your system up per subcooling or superheat, as well as amperage. That's a good rule. And then after that, you take readings, your temperature difference going across the evaporator coil. You want to make sure that you're in the range between, I would say, 15 to 21. Newer systems, 18 to 21. Old systems, 15 to 21. So, yeah. Anyways, Omar, AC Power and Comfort, Redstone, I hope this was helpful. Ruben, keep going on the right track for HVAC, man. There's a lot of other stuff out there besides, you know, besides this. There's, get involved in the HVAC for heavy equipment, as it's more of a challenge. It's more of a challenge, and I love challenges. When you start dealing with residential, and some people pick their niche. The industry for commercial and industrial, that's where challenges are more are at. So anyways, AC Power, Omar, thank you for viewing.